right, we're going to work on evaluating a composite for our trig expression. So this 5/12 is not on the unit circle. So we work in the innermost parentheses first when you do composites. So it's saying take the tangent inverse of 5/12. So our output should be an angle measure when we're done with that green section. So we need our angle theta to be an angle between negative pi over 2 and pi over 2, because that works with the half moon. So we're going to work with 5/12. So we say theta equals the tangent inverse of 5 divided by 12. And we want to find out what that angle is. So this angle, since it's a positive tangent, would have to fall in quadrant 1. Because tangent in quadrant 1, the sine value over the cosine value is 1. So here's your angle theta, and then you have your side opposite, which is your y distance. Your side adjacent is your x distance, and then you have your point up here, x comma y, and then you have your radius, which is the distance from the origin to that point. So we're looking for who is your y and who is your x. So if you remember, the tangent of an angle is the sine value over the cosine value, or the y over the x. So since we have a fraction, that 5 is our y value, and the 12 is our x value. So we're going to go ahead and label that on our right triangle. So this distance is 12, and this distance is 5. Now we're going to find that missing third side of the triangle, r. So we're going to use the Pythagorean theorem. X squared plus y squared equals r squared. Now we sub in. The x is 12 and the y is 5. We square those numbers. 144 and 25. Add them together and you get 169. Then we want to undo that square root to undo the r squared, and we get r equals 13. So that radius is 13. So now we're going to go ahead and work out. So we've found that the angle is in quadrant 1, and now we're going to take the cosine of this right triangle. So the cosine is taking side adjacent, which is 12, over side hypotenuse, which is your radius. So the cosine of an angle is taking the x over the r, or adjacent over hypotenuse. So what do we get there? What is x over r? Well, that's 12 over 13. So this answer up here is 12/13. Let's do one more of those. So example 8, we want to find the composite for this trig expression. So we're going to work in the innermost parentheses first, and it's saying take the sine inverse of negative 1/3. So this is a inverse function, so our restriction is going to be between negative pi over 2 to pi over 2 for our angle. So we're looking at the half moon. So our angle is going to fall between negative pi over 2 and up here at pi over 2. Well, this angle is not on the unit circle, so we have to create a reference triangle. So the sine of the angle is opposite over hypotenuse, or your, which is, here's your opposite, and then here's your hypotenuse, which would be y over r. So we have to choose which one's going to be the y. So that's going to be either a positive or negative 1. And then your radius, your r, is 3. So since this is going to be a radius that's positive, we have to choose the y to be a negative 1. So now let's go ahead and create our reference triangle. So here would be the start on the x-axis. I'm going to create our triangle. This is our x distance. There's our reference angle. This is side adjacent. This is our y distance, side opposite. Here would be our point, x comma y. That's not on the unit circle. And then our radius out to that point. We're going to go ahead and substitute into our right triangle these two numbers, negative 1 and positive 3. So our side opposite is down 1, and our radius is 3. And we're missing what this x value is. So we're going to go ahead and use the Pythagorean theorem again. So we're going to do x squared plus y squared equals r squared. So x is unknown, y is negative 1, the radius is 3, and we're going to solve this for x. So we're going to square those numbers. Then we're going to subtract 1 and simplify it. Now we want to undo that x squared, so we're going to square root both sides. And then simplify that. So the square root of 8 can be rewritten as the square root of 4 times the square root of 2, and then the square root of 4 is 2. Now we can't have plus or minus, we have to choose one of them. So we're going to look up into this x value. Notice that it's going in a positive direction, so we'd have to have a positive 2 square roots of 2. So our x value is positive 2 square roots of 2. So you'd want to write that on your figure, 2 square roots of 2. Now we know all three sides in our triangle. We know the length of x, we know the length of y, and we know the radius. Now we can go out and find the value of any of the 6 trig functions. So I'm going to change colors here. And now we're going to take the cotangent of this triangle. Cotangent of an angle is the reciprocal for the tangent. So tangent, if you remember, is y over x, or this side opposite over adjacent. So to find the cotangent of that triangle, we're going to do the opposite. We're going to take x over y. So let's go back up. Who is my x? 2 square roots of 2. Who is my y? Negative 1, and we're going to divide those. 2 square roots of 2 divided by negative 1, and then simplify it. So our final answer for this problem, which was a composite, is the cotangent it's not letting me right here, cotangent of the sine inverse. Something going on with my pen here. I'm not sure. I'm going to change colors here. Of negative 1/3 is negative 2 square roots of 2.